Lesson 5, naming and writing formulas for covalent compounds. We can also call them molecular compounds. And our objectives for this lesson will be to name them and learn how to write their formulas. So on page 17, we're going to look at the IUPAC, International Union for Pure and Applied Chemistry, naming rules for covalent compounds. So let's recall a covalent compound consists of a nonmetal and another non-metal or non-metallic element. Binary, so the prefix bi equals 2, so that helps you. Binary compound, 2 elements bonded together. So for example, carbon dioxide, 2 elements. The subscript tells you how many atoms of each element. Okay, so remember right here, subscript is number of atoms, not the number of elements. And ternary, so the prefix ter or ternary means 3. Okay, so this is where we're going to say there's 3 elements bonded together. So we can break down our covalent compounds into either binary or ternary compounds. So the procedure for naming covalent compounds is very similar to the procedure for naming ionic compounds. The only difference, however, is that you use prefixes to designate how many of each element you have in the covalent compound. I prefer naming covalent compounds over ionic compounds. These are actually a lot easier once you memorize all the prefixes. The following are the prefixes you will use. So for 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 septa or hepta, 8 is octo, 9 is nona, and 10 is deca. One exception that we have to look at, and again, many exceptions in science. So one exception would be to drop the mono prefix if there is only one atom of the first element in the compound. Okay, final O's or A's of a prefix are dropped when an element begins with a vowel. So for example, carbon monoxide. Oxygen starts with an O, so we're not going to say monoxide. We're actually going to drop the O and make it mon and then oxide. So again, the same rule applies for the nonmetal naming. We drop the ending and put the IDE. So rules for writing chemical formulas of covalent compounds. The least electronegative element is written first. So you have to look up electronegativity values on table S to find this out when we write out the formulas. All right. The most electronegative element is written second. Subscripts will tell you the prefix of each element in the formula. So for example, carbon is by itself, and we're not going to say monocarbon because remember it's our exception. We drop the mono if it's the first element and there's only one. And then there's 2 oxygens, so the prefix tells us that we have to use the di because there's 2, so carbon dioxide. And that's misspelled, it should be dioxide. Alright, so let's do some practice. It's the best way to learn how to do it. So name the following compounds. We have carbon and we have oxygen. Again, the first element gets named. There's only one, so we're going to say carbon. And then we have 1 oxygen, so the prefix for 1 is mono, okay? But we're not going to say monooxygen, we're going to say mon and then oxide. The O gets dropped and then the oxygen because this starts with a vowel. The next one, carbon, Again, do not say monocarbon because we don't do that for the first element. So it's carbon, and then there are 2 oxygens. So we're going to use the prefix di. We're going to say carbon dioxide. Next. Okay, so here's a little tricky. We have 2 of the first element. So the 2 tells us we're going to have to use the prefix di, and it sounds funny, but it is correct. Dinitrogen. And then the next one, monoxide. N2O5, again, 2 nitrogen, so we're going to use di-nitrogen. And then we have 5 oxygens. So for 5 oxygens, we're going to use the prefix pent. Okay, and we're going to say pent oxide. Remember, the A for penta, the A gets dropped because oxygen starts with a vowel, so it would be pentoxide. The next one, carbon, is the first element. And then we look at the second one is chlorine, okay, which is also a nonmetal. And there are 4 of those, so we're going to use the prefix tetra. And it doesn't start with a vowel, so we'll continue to use the tetra. We don't have to drop the A. Tetra chloride. All of the endings of binary compounds have to end with IDE. Okay? And then the last one here, sulfur. And then we have 6 fluorines. So that's going to tell us that we're going to use the prefix hexa. And we're going to say hexafluoride. Okay. So here's a good one for you, H2O. What would be the covalent compound name for hydrogen? 2 hydrogens and an oxygen. For water, dihydrogen monoxide. So this would be the IUPAC system naming, or the stock system naming for water. Last but not least, let's give the formulas for the following compounds. So we've named them, which was our first objective, and now our second objective is to write the formulas. So nitrogen monoxide. Here we have to say to ourselves, all right, all we need to do is look at the prefixes to tell us how many of each. We don't need to look at charges. We don't need to do anything. Okay, so here it says nitrogen, so we know there's only going to be 1. It says monoxide, 1 oxygen, so NO. Carbon, first nonmetal. Tetra is equal to 4, so this is going to be CF4. Bromine, symbols BR. Penta is equal to 5, so we have 5 chlorines. And dinitrogen, so this is going to tell us that we have 2 nitrogens and 5, so I'm going to say equals 2 equals 5 sulfurs. And then we have sulfur, tetra, again, 4 bromines. And that is it. Very simple. I believe that the covalent compounds are the easiest to actually write formulas for because we don't have to do the crisscross, no crisscross method. Okay, simply look at prefixes to determine the subscript. Okay, so what I'd like you to do is try to do some more practice in your homework packets. So you would go to the next page for covalent compounds, naming, and writing formulas.